Okay, so in this video, we want to review the product rule and the formula for the derivatives of some special functions. So let's first remember the general product rule with respect to x. So if we differentiate the product between f of x and g of x, the derivative will work out like this. Derivative of the first function, f prime of x, times the second gx, plus, and now we flip the role of the derivative, plus the first function f times the derivative of the second function. And this is the product rule. Let's consider now some examples. So what about the derivative of 2 to the x arctan of x? So we clearly have your product between 2 to the x and arctangent of x. So we apply the product rule. Derivative of the first function, 2 to the x, remember, ln of the base. This is the derivative of 2 to the x times the second function, arctan of x. Plus now, the first function 2 to the x times the derivative of arctangent of x, if you remember, is 1 over x squared plus 1. And that's it. And again, I will leave the simplifications up to you, as the goal of this video is simply to review the product rule and not algebraic simplifications. For example, here you could factor a2 to the x from both terms. We could look at the derivative with respect to x again of 3 x to the 8th sine of x. Now the idea here is not to drag the 3 in the differentiation, as 3 is a constant multiple of the whole function of x. It will stay up front as a constant multiple, so we think of the derivative of 3 times this function is really just 3 times the derivative of this function. So we apply the product rule once again. Derivative of the first function, power rule 8x to the 7, times the second function, sine of x, plus the first function, x to the 8th, times the derivative of sine, and if you remember, that is cosine of x. That's it. But if we differentiate, with respect to y now, e to the y times the secant of y. Now if you remember, when we have the natural exponential, the derivative of e to the y with respect to y is itself, times secant of y, plus e to the y times the derivative of secant of y. If you remember, the derivative of secant is secant tangent. So secant of y, tangent of y, and there you go. You could of course here factor out e to the y secant of y from both terms. Let's look at one last example. What about the derivative now with respect to t of the logarithmic function base 3 of t, so log base 3 of t, times the tangent of t? Well, the derivative of log base 3 of t, if you remember, is 1 over t times the natural ln of 3, so 1 over t ln of 3, times tangent of t, plus the first function, log base 3 of t, times the derivative of tangent, which is secant squared. And that's it. So always remember, the derivative of a product is the derivative of the first function times the second, plus the first times the derivative of the second.